Welcome to Pomodoro Joe for Monday, August 21st, 2023. Today we're looking at LeetCode problem 459, repeat substring pattern. This is an easy problem. Given a string S, check if it can be constructed by taking a substring of it and appending multiple copies of the substring together. All right, so our examples here, we have A, B, A, B, and this is true because you can take A, B and just repeat it twice. Next example, ABA, this is false. There's no substring that you can just repeat to get ABA. And finally, example 3, ABC, 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 ABC. It's true because you can repeat ABC 4 times. All right, so I think this is pretty straightforward. So we'll put 25 minutes on the Pomodoro timer and we will get started. So first, let's just do the brute force approach. We'll essentially take every possible substring up to a point, and we'll just try to repeat that substring as many times as we need to create a string the length of our input string. Then we can compare our input string to the substring that we just created, or this new string that we created with our substrings. If they're the same, we can return true. And if they're not the same, then we repeat with the next substring. All right, so let's start with this. We need to know the length of our string first. So that's just going to be length of S. All right, now for every substring pattern, now we only need to go to our length of S divided by 2, because once we have a substring that's longer than half of our length here, if we put 2 of those together, we'll be greater than the length of our string. So our upper limit is actually this length divided by 2. So I'll do upper limit, that's going to be our length of S, and that's going to be an integer divided by 2. Cool. All right. Then for every, I'll call it substring length, in range from, we'll have at least one element in our substring. So from 1 up to our upper limit. And since range is not inclusive, we have to do upper limit plus 1. So for every substring that has a length between 1 and our upper limit, we'll just create a substring, and then we'll try to repeat that substring as many times as we need to make a string the same length as S. So that's going to be, let's see, our substring here. We'll just take S and we'll grab everything between 0 and this current substring length. All right, so this will give us a substring that starts at 0, the index 0 of S, and goes up to, but not including this substring length. So for our very first substring, we're just going to get the first character of S. For the second substring, we'll get the first 2 characters of S, and so on. Next, we need to figure out how many of these substrings we'll need to put together to create one of our S's here. So let's see. Well, I know the length of S, and I know the length of my substring. So I have my multiplier. That's just the length of my S. And that's an integer divide by my substring length. I'll just copy and paste this. All right, so that's going to tell me how many of these substrings I need to put together to create one string S. So for this, I can have my test string, I guess. Maybe I'll call it test S. And Python lets me do a simple multiply, so I can just say test S is my substring times my multiplier. Now, other languages, you might have to create a for loop and just go through your for loop multiplier number of times and then append these substrings together. And then finally, here, I can say if my S is equal to my test S. So I've created a string out of substrings. If they're the same, if that string is the same as my input string, then I can return true. If it's not, and I go through all of my possible substrings, then I have to return false. All right, let's check this out and see how it goes. Okay, that seems to work. Let's submit this and see if we can pass all the tests. And we pass. We don't do very well though. You can see we only get a 33% for runtime and a 76% for memory. So this isn't great, but it works. All right, so this is the brute force solution. Just go through and try every possible substring. All right. There is another way to do this that's a lot faster, but it's going to take a little bit more thinking. So instead of doing all of this, let's just take a quick look at one of our examples. So let's look at maybe AB, AB. That's a good one. Or let's try ABC. I like that. So we'll do ABC, ABC. Okay, so if this is our input string, we have ABC, ABC. We want to see if there's some substring in here that we can just duplicate multiple times to create this input string. Well, one thing we could do is just take two of these input strings and put those together. So we have ABC plus ABC. Then what we kind of have in here is some, I'll call it like prefix part. So that's some prefix plus our original S plus the postfix. Or suffix, that's probably the right word, suffix. Okay, what do I mean by this? So I took our original input string, I doubled it. Now, this had to have been on a boundary. If there's a way to do this, this ending has to be on a boundary, which means that I should be able to slam two of these together, which means that our original input string is somewhere contained in here, plus some part at the beginning and some part at the end. So we can say that this is like our prefix and our suffix. And you can see this is where our original split occurred, but our input string is actually in here somewhere. So one thing we could do simply is we could have some test string, but instead of having our test string be some buildup of multiple substrings, we can just say this is going to be S plus S, or S times 2. So now if we were to look for our S inside of our test S, we will definitely find it because there are two of them there. We need to sort of remove those complete strings. We need to replace them with partial strings so that we just have the part in the middle that could possibly be a complete S. Hopefully this is making sense. So let's actually set our test S equal to our test S from the first character on. So we are going to drop the first character from our test string. And then we're also going to drop the last character from our test string. So the test S will now equal test S up to, but not including, our last character. So we take our original input string, we double it, so it's two of them stitched together. Then we're going to drop the very first character and the very last character, which means that we no longer have two complete S's in our string here, our test string. We've dropped one character from each side. So if there is a complete string, complete S, it has to be somewhere in the middle of our test S here. So now we can just return if S is in our test S. All right, let's run this, see how it goes. Okay, that still works. Let's submit this, see if we do any better. And we do a lot better. Now we're beating, whoa, 99% for runtime, 98% for runtime, and 75% for memory. So that is a huge win over our brute force approach. Now, this one I am not describing very well. All right, well, that's it for me. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code. Oh, and by the way, if you're still watching, yes, I did miss a couple awesome problems over the weekend. I was away and I couldn't get to those problems, but I will try to get to them sometime this week. However, they look like doozies. I don't know if I'm going to have enough time. I'll see what I can do. All right. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.